we are on the third type of organic reaction that we should know at this level. So remember, we've already spoken about addition, elimination, and now we're speaking about substitution reactions. And there are three types of substitution reaction that you need to know at your level. The first one is halogenation, and you'll see how that reaction or process proceed. The second one is hydrolysis, and then the last one would be hydrohalogenation, right? And then remember, for substitution reaction, so we normally have a saturated molecule, and then the product as well also be saturated. So by now you know the difference between saturated molecules and unsaturated molecules. Okay, so let us start. So how do we define substitution reaction? So substitution reactions happen when an atom or a group of atoms in an organic molecules are replaced or changed or exchanged, or whatever word you want to use it, for another atom. So we might maybe we have chlorine, we want to replace it with I don't know, what can we replace it with? Maybe we want to replace it with hydrogen, whatever. So it's that exchange. So now the important thing, like I mentioned, is that substitution reactions can take place between compounds that are saturated, alkanes or haloalkanes, as well as alcohols, right? So it's important for you to know that. So let us start with the first type of substitution reaction that you need to know. The first one is halogenation. And I think just by looking at the name of it, you should already know what happens in this. And this is when we substitute, I hope this is the correct, is it a D or a T? I don't know. We substitute either chlorine or fluorine or what, all those compounds, all those atoms that you find in group 7 of the periodic table, right? So for example, we can start with an alkane and then have a whatever it is, our halogen, and then at the end we're going to get a haloalkane, right? We're gonna get a haloalkane. So let us do that. Let us say we had our alkane with propane. So we know propane has 3 C's in its chain, and we're gonna halogenate it. So we're going to add, so let's say we're going to add fluoride, so F2, right? And then what are we going to do? So it means that to substitute, we're substituting one thing for another. So I can write this F2 like this. You can just write F, where that is bonded fluorine, that is bonded to another fluorine atom, right? And then what we get is that we're going to substitute a hydrogen. Let us substitute this one. So this means that we will have HCC, have our fluorine there, F, H, H, H. But you also noticing something, you should notice something from this. I don't know why I removed that. So you should also notice something, that we only substituted one atom of fluorine, took this one off, meaning one of our products is also going to be HF, right? Cool. So we had propane, fluorine, and then our thing here, it's going to be 2-fluoropropane. Hopefully you know how to name these organic molecules by now. And some of the reaction conditions for this type of reaction is that it needs to take place in the presence of sunlight. So there must be sunlight or at least heat. You might be asked to give the reaction condition for halogenation of alkanes in a question, right? And then the second type of reaction that you're going to be focusing on is hydrolysis. Hydrolysis. So that's hydrolysis of haloalkanes. That means that we start with a specific haloalkane. Let us say in this case we had 2-chloropropane, and we started with it. trying to be as fast as I possibly can be. And then we add water there, right? Or sometimes people can add sodium hydroxide, or they can add potassium hydroxide. Doesn't matter. So let us say for our case, we were adding water. So we had, should I say water or potassium? It's fine. Let's say water, H2O, right? And then what you're going to find is that the OH from the water molecule is going to substitute the chlorine there, right? So meaning at the end, we're going to be left with an alcohol, which is propan to all in this instant. So you see how this proceed. And then obviously we took one H and oxygen from here. It means that we are still left with a hydrogen. This hydrogen that comes from water molecule will bond with the chlorine and will form HCl, or hydrochloric acid. Cool, right? And then the reaction condition for this is that this haloalkane has to be dissolved in an ethanol. So the haloalkane must be dissolved in an ethanol solution. And the entire film must be treated with a hot aqueous sodium hydroxide or potassium hydroxide solution. So those are some of the few things that you need to know. And now let us take the third type of substitution reaction that you need to know. So the third type of substitution reaction that we need to know is what we call hydrohalogenation of alcohols. So what this is telling us is that we normally start with an alcohol. Let us say in this instant we had a tertiary alcohols, meaning the carbon bonded to the carbon with the, now this is, let me do this. So the carbon bonded to the carbon with the OH group is bonded to 3 other carbons. We've already spoken about primary and secondary alcohols in the previous lesson, so I'm not gonna repeat myself. And then we were perhaps adding HBr. It can also be HCl or HI or HF. So these are just your group 7 atoms, right? Your halogens, right? Okay, cool. So in this instance, let's say we were adding HBr, right? And then we substituting this, so meaning we are removing this. So it's a tertiary alcohol, right? Meaning it's going to form a tertiary haloalkane. You know by now what that is because we've already spoken about it in the previous lessons. If you don't know, please refer to those lessons. Correct. So meaning we will now replace the OH with the Br there. With the BR there. I've been lazy to go buy markers of the BR there. And now if we take BR there, we are left with H, and this H is going to react with the OH, meaning it's going to form H2O. So water is released in this process. Try to see if you can actually name these compounds. You should be able to by now. Okay, so some reaction conditions, especially with respect to hydrohalogenations of tertiary alcohols, is that the hydrogen halide, this we call hydrogen halide because it has hydrogen and a halogen atom. So the hydrogen halide must be present at room temperature. But then if the hydrohalogenation occurs for primary and secondary alcohols, the reaction conditions differ, and that in that instance you actually need high temperatures, and it needs to be treated with sodium bromide or concentrated sulfuric acid. So those are a few things that you actually need to know with reference to these types of reaction. And yeah, this brings us to the end of this lesson. I'm glad that it wasn't a long lesson, and yeah,